video, we are going to learn about the modulo arithmetic explained with the help of division algorithm. Let's take a brief look on the division algorithm. In mathematics, when we divide any integer with a second positive integer, in that case, it gives you a quotient and the remainder. It means if we divide A with D, we get Q and R, where Q is called as a quotient and R is called as a remainder. In this case, A is called as a dividend and D is called as a divisor, where R is always greater than equal to 0 and less than divisor. With the help of this equality, we have two different notation that is expressed in terms of quotient and remainder. The first notation is when A is divided by D, we can have a quotient. So when I write A divide D, we will write the answer in form of quotient. And in case we write A mod D, mod means we are working with the remainders. Let's understand with the help of example. Suppose what are the quotient and the remainder when 101 is divided by 11. So when I need a quotient, basically we can write 101 divide 11. So quotient in this case we have 9, and if I write 101 mod 11, it means when we divide 101 with 11, what is the remainder in this case? That is 2. Basically, 101 when divided by 11, quotient is 9 and the remainder is 2. In short, when we write this notation, we need quotient, and when we use mod, it means we need remainder. Let's take another example. What are the quotient and the remainder when minus 11 is divided by 3? In this case, we can write minus 11 is equal to 3 times of what plus something. So basically we need to find quotient and the remainder. One way is we can write minus 11 is equal to minus 3 times of 3 plus minus 2. When you write in this case, the remainder is a negative, but in the division algorithm, remainder is always positive. In short, this is the incorrect way to write this one. So it means quotient is not is equal to minus 3 and the remainder is not is equal to minus 2. So we sublet this negative of 11 as negative of 4 into 3 plus 1. So now you check it whether this is equal to minus 11. Yes. So minus 4 into 3 is minus 12 plus 1, that is equal to negative of 11. So now we can say that quotient in this case is minus 4 and the remainder is equal to 1. Whenever you are finding the remainder, if you get as a negative remainder, there is a key to get as a positive remainder. What you need to do? Here, negative remainder get converted into the positive one by just adding the divisor. Divisor in this case is 3. So minus 2 plus d, that is 3. So we can write minus 2 plus 3 is equal to 1. Surely remainder is 1. Now here what we can write? We can write a is minus 1, q into 3 plus 1. Find the value of q from here. You will get a q as minus 4. Always remember that remainder is never negative. Next we have modulo arithmetics. Now what is a modulo arithmetics? Suppose we have any two integers a and b. We call these two integers are congruent with respect to the mod m, where m is a positive integer if m divides a minus b. First we will learn the notation, then we will understand what is the meaning of this one. Here A is congruent to B mod M is represented by this notation. So we write A is congruent to B mod M if it satisfies this condition. Let's take an example. If we can write 4 is congruent to 2 mod 2, it means we just need to check whether this M mod 2 divides 4 minus 2 or not. If yes, it means this notation is correct. So 2 divides 2, yes, it means this notation is correct. Now if I say that 4 is congruent to 7 mod 2, is this is correct? Let's check it whether 2 divides the difference of these two numbers, that is 4 minus 7. 4 minus 7 is minus 3. Whether 2 divides minus 3? No. So it means they are not congruent, and in short we write 4 is not congruent to 7 mod 2. So we use this notation when these two numbers are not in congruent form with respect to mod m. Let's take another example. Determine whether 17 is congruent to 5 mod 6 or not. What does it mean? We just need to check it. Can we write 7 is congruent to 5? Here we use mod 6. Means we are dividing by the 6. So we just need to check whether 6 divides the difference of these two numbers or not. That is 17 minus 5. 17 minus 5 is equal to 12. So we just need to check it whether 6 divides 12. Here 6 is dividing 12, or we can write whether 12 by 6 is any integer. Yes. Here we get 2. If yes, it means we can say that yes, 17 is congruent to 5 mod 6. Now check whether 24 and 14 are congruent with respect to the mod 6. Means can we say that 24 is congruent to 14 mod 6? How to check this one? Whether 6 divides 24 minus 14. 24 minus 14 is 10. So whether 6 divides 10, or we can say that 10 by 6, whether this is an integer. So this is not is equal to any integer, as it is a rational number, or we can say that it leaves the remainder. Due to which we can say that 14 is not congruent to 24, or 24 is not congruent to 14 mod 6. Now you will feel confident about the congruency when you know this result. When we say that two numbers are congruent when divided by any number m, that is only possible when they leaves the same remainder when divided by m. Means when we divide a by m, find the remainder, and find the remainder when b is divided by m. In case the remainders are same, it means A is congruent to B under the modulo M. And make sure we are working with the remainder and it should be non-negative, means positive remainders. Let's understand the previous example with respect to this result. We have taken the 17. 17 is congruent to 5 mod 6. Now when 17 is divided by 6, what is the remainder in this case? Remainder is 5. Now when 5 is divided by 6, remainder is what? As this number is less than 6, so we cannot divide this number by 6. In short, it is a remainder itself, 5. On the both the side, remainder is 5. hence they are congruent. Let's take the second case. 24 is congruent to 14 mod 6. Whether this is true or not, let's understand with the help of this result. 24 when divided by 6, remainder is 0 because that is exactly divisible, and in this case 14 when divided by 6, remainder is 2. So we can say that 0 is not is equal to 2 mod 6. Hence, they are not congruent. Another result we have, let m is any positive integer. A is congruent to B mod m. C is congruent to D mod m. This is given to us. It says that when we add A and C and B and D, still the congruency is preserved. Even if we multiply these two terms, still the congruency is preserved. Let's understand with the help of example. Take A is equal to 4, B is equal to 1 and M is equal to 3. On the same case, take C is equal to 8, D is equal to 2. First, we need to check whether these two congruency is maintained according to these numbers or not. So, check whether 4 is congruent to 1 mod 3. Yes. How? Either we can use the definition. Definition says that 3 divides 4 minus 1. Whether this is true? Yes. Second, we can use the result whether both side remainders are same when divided by 3. Yes. 4 when divided by 3, remainder is 1. 1 when divided by 3, as it is less than 3, so remainder is 1. Both sides the remainders is 1, so hence they are congruent. For the second case, whether 8 is congruent to 2 mod 3? Yes. When 8 is divided by 3, remainder is 2. So both sides the remainders are same. It means 8 is congruent to 2 mod 3. Now check it whether A plus C is congruent to B plus D mod M. A plus C is 4 plus 8, that is 12. That is congruent to B plus D, 1 plus 2, 3, mod 3. Either check it by the definition or by remainder. If we calculate the remainder, 12 when divided by 3, remainder is 0. 3 when divided by 3, remainder is 0. Both sides the remainders are same, it means they are congruent. In short, A plus C is congruent to B plus D mod M for every integer. If you want to proceed by the definition, we need to check it whether 3 divides 12 minus 3. That is 3 divides 9. That is 9 by 3. That is exactly divisible? Yes. Similarly, check the second case, A into C. That is the 4 into 8. 32 is congruent to B into D. 1 into 2. That is the 2 mod 3. This is applicable by using the result. Calculate the remainders. 32 when divided by 3, remainder is 2. It means with the help of result, they are congruent. Now as per the definition, 3 divides 32 minus 2. That is 30 upon 3. That is exactly divisible? Yes. So we can say that this is valid and hence this result is also valid. Next we have arithmetical modulo m. In this case we have two different operations that is defined with the help of modulo. The first operation is additional modulo m and the second is a multiplication mod m. The notation used for the additional modulo m is this, whereas for the multiplication this. Now what does it mean? Basically, when we write additional modulo m over the two integers, it means we need to find sum of two integers and then find mod m. Means find the sum of two integers Divide that with m. After that, whatever the remainder we have, that is the final value of this. In case of multiplication mod m, we will product the number and then calculate mod m. That is the value of this expression. Let's take an example. What is the value of these two expressions? Here we need to add these 7 and 9 and then take mod 11. 7 plus 9 is 16. This is equal to what? 16 when divided by 11. Remainder is 5. So it means this expression equivalent to 5. What about this one? In this case, the operation is multiplication. So it means we need to take the product of 7 and 9. After that, we calculate mod with respect to 11. This is equal to 63 mod 11, and that is further is equal to 8. So this expression is equal to 8. So note that whenever we are performing any arithmetical modulo m, either addition or multiplication, we need the value less than m and greater than 0. In short, arithmetical operation is defined on the set of non-negative integer less than m, which is represented by Zm. In this case, the expression value is equal to 5 and 8 respectively, and that belongs to the Z11, where Z11 indicates that take all non-negative integers less than 11 till 10. Basically, what are the possible remainders when divide any integer with 11? Collect that one in a one set, that is the Z11.